Hello, we are the GenomicSequences team and I am going to show you an introductory video about the Genome Pro web application. Nowadays, biologists, researchers, and health professionals do not have the resources to identify computationally the sections of the human genome that are significant to study and prevent biologic disease processes due to the increasing production of genomic data. The reason to this problem is that there is not currently an automated system that can accelerate this process and produce a proper result. In addition, the current system for processing genomic sequences is being done manually, and this process could take days and even weeks to obtain an accurate result that can be error-free. This was our schedule for the entire semester. We divided it into sprints to make it more readable. Here we have the project planning and the sprint 1. Here we have the sprint number 2. Here we have sprint number 3. Here we have sprint number 4. And finally sprint number 5 and the sprint release. Now we are showing the user stories that the team implemented during this semester. We had a total of 5 sprints. This is the use cases diagram for the implemented user stories. Our system will have 2 actors, users and an admin. Now we are showing the sequence diagrams for the most important part of the application, the algorithms. This is the find repeated sequences diagram. This is the analyze types sequence diagram. This is the find genome probe sequence diagram. And finally, this is the find genome difference sequence diagram. The GenomicSequences application provides a model view controller system design. The model represents data, business logics, and rules. The view represents the presentation. Finally, the controller accepts input and provides a bridge of communication between models and views. This is the deployment diagram for the GenomicSequences application. The users will be able to access the application from any web browser. Here you can see the persistent data design used to develop our data storage. We have a users table, a documents table for all the data uploaded by the users, and one table for each of the tools working on the application. Our application security and privacy is defined by a secure registration process where the user is able to log into the system only if the email provided is valid and if the user activates his or her account through the email. Also, we hash our user's password. We validate all data entered by users before accessing our data storage system, and we have access control rules as well. Here are the minimal class diagrams for the most important part of our application, the algorithms. This is the find repeated sequences minimal class diagram. This is the analyze data types minimal class diagram. This is the find genome probes minimal class diagram. And finally, this is the find difference minimal class. This is the state machine diagram for the most important part of our application, the files controller, which makes sure that every imputed data is handled carefully. Now we are presenting screenshots of the main algorithms that we have been describing since the beginning. This is the find repeated sequences main algorithm. This is the analyze data types main algorithm. This is the find genome probes main algorithm. This is the find differences main algorithm. Here we are presenting the validation process for each of the algorithms, one sunny day and one rainy day for each. This is the find repeated sequences sunny day and the find repeated sequences rainy day. Also, we have the analyze data types sunny day and rainy day. We have the find genome probes sunny day and the find genomes probes rainy day. And finally, we have the find difference sunny day and the find differences rainy day. Finally, these are the automated test scripts for each of the algorithms we have been described. The find repeated sequences automated script, the analyze data types automated script, the find genome probes automated script, and finally the find differences automated test script. Now I am going to show you the Genome Probe application high-level demo. Now I am going to show you the basics of using Genome Probe, which is a free application for studying the human genome. In order to be able to use Genome Probe, the first thing you need to do is register. Once you are in the registration page, please enter the following information and click on register. You will receive an email to activate your account. You should have received an email like this one, saying that you have registered to Genome Probe. Please click on the link Activate to activate your account. Once you activate your account, you will be redirected to Genome Probe main page. Now that you have activated your account, you can log in. This is the user's profile page, where you can change your name if you made a mistake while registering, upload a profile picture, and also change your password. On the top right of the navigation bar, you can see the Tools tab and History tab. Under the Tools tab, you will be able to find, analyze, and compare genome data. Under the History tab, you will be able to see the history of the files that have been submitted by you to the application. Let's go into the tools to show how to use them. Here, you will see the GenomicSequences tools available. Each one does a specific task. Each tool has a description of what it does. Let's use them to show what they do. The first one is find repeated sequences. Select a genome sequence file and click on find. A message will be presented to you saying that the file has been unloaded to find the repeated sequences, and email will be sent to you with the results. You should receive an email from the Genome Probe team saying that the result of the repeated sequences on this file is in the attached result. When you click on the file, you will see the result file. We're gonna see now the genome data type. If you choose a file and you open it, you click Analyze. The system will tell you that the file was already submitted. You will see the result, and it will tell you the data type of that file. In this case, it's DNA. Now we're gonna use the Genome Probe. Select a genome file, and select a batch file and click on find. Once again, the system tells you that the file has been unloaded to find the genome probes, and an email will be sent to you with the results. The results of finding the probes in the first file given the batch file is in the attachment file. If you click on the file, you will see the sequences, the times that are repeated, and in which line they are present. We click on genome differences. We choose a genome file, and we choose another genome file, and we click on find. The system will tell you once again that the file has been uploaded to find the difference among them, and an email will be sent to you with the result. Once again, you will receive another result telling you that the result of finding the differences among this file and this file is in the attached result file. If you click in the result file, you will see the the sequences that are in the first file that are not in the second file, and then the sequences that are in the second file that are not in the first file. Now, if we go to history, we will see all the files and results produced for each of the GenomicSequences tools. The history page is presented in a way that it is easier for the user to view and not get confused. Here is the history for the repeated sequences, where you can also see a graphical representation of the result. Now, if we go to genome data type, you will see the history for genome data types, the genome probes, and the find differences. You can also download to your computer any file you want in case you lose it. For example, this result file. You can download it to your computer and you can have the result. Well, that was all. Thanks for watching.